Hello everyone, we are here today to learn about the excitation system of synchronous generator. I am today's main instructor, Luo Qiang. Today's lesson is divided into three parts. The first part is basic principles of synchronous generator and excitation system. The second part is the development and evolution of the excitation system and excitation control. The third part is technical standards for excitation systems. Let's start with the first part, basic principles of synchronous generator and excitation system. As we know from our secondary school physics or our professional prerequisite course, electrical machines, a current is generated in a conductor when the conductor moves through a magnetic field and cuts through the magnetic lines of force of the field. This is the basic principle of a generator. This shows that to generate electricity, two conditions must be met at the same time. First, there must be a magnetic field that produces magnetic lines of force. Second, the moving conductor must cut the magnetic lines of force. The excitation system is the control system that generates the magnetic field of the generator. The generator consists of two main parts, the rotor and the stator. The rotor winding in the rotor are energized with DC current to generate the magnetic field of the generator. The stator winding in the stator are cut by the magnetic lines of force of the rotating magnetic field, generating current in the stator winding. The rotor of the generator is dragged around by the prime mover, which can be a hydraulic turbine, a steam turbine, or a diesel engine. And thus the magnetic field generated by the rotor winding is also rotating, generating a relative motion with the stationary stator and stator winding. Here's a model. The rotor has only two poles, so the frequency of the induced voltage, which is the same as the rotor speed per second, is a synchronous alternator when the speed is 3,000 revolutions per minute. The frequency of the three-phase alternating current emitted is 50 Hz. These two-pole synchronous generators are widely used in coal-fired gas turbine and nuclear power plants. These plants use a steam or gas turbine with a speed of 3,000 R per minute to drive a synchronous generator that produces a direct current, the magnitude of which can be controlled at will to the generator's rotor winding. This is the most basic function of the excitation system. This current is the excitation current. The actual generator excitation system is more complex than that. It's a combination of many disciplines, including power systems and its automation, electronical engineering, electronics and power electronics, principles of automatic control, electrical techniques, industrial automation, microcomputer principles and interface technology, C programming language, relay protection, etc. The second part is the development and evolution of excitation system and excitation control. The excitation system is an important part of the synchronous motor. It is a set of systems to supply DC excitation power to the motor, including excitation power, regulation and control equipment, as well as other auxiliary protection and measurement equipment, etc. Excitation control is a control system that controls the electrical motive force of a synchronous generator. So it controls not only the terminal voltage of the generator, but also parameters such as the generator's power factor and current. Because these parameters of large generator sets directly affect the operating state of the system. So to some extent, it can also be said that the excitation control also controls the operating state of the system. Especially the stability of the system is closely related to the excitation control. In the last 20 to 50 years, with the development of the power system and the increase of unit capacity, the excitation of synchronous generators and their control systems have changed a lot, mainly in first, semiconductor excitation instead of DC excitator. In the past, synchronous generators are used with its coaxial DC generator to provide excitation current with the increase in generator unit capacity, and its required excitation capacity also increases. Manufacture of such a large capacity, high-speed DC generator obviously has a lot of difficulties, such as complex and unreliable mechanical rectification, carbon brush wear, easy to spark, etc. So the limit capacity of the DC excitator of the turbine generator is generally not more than 350 to 450 kilowatts. The rotational speed of the hydro generator set is low. Mechanical rectification does not appear to be particularly difficult, but the limiting capacity is limited by its own size and volume. If the volume of the exciter size is too large, the length of the unit increases. It will make the height of the hydroelectric power plant increases. It seems unreasonable economically. Therefore, nowadays, turbine generators and hydro generators with a capacity greater than 150 megawatts do not use coaxial DC motors. As an exciter, almost all with semiconductor rectifier power supply DC excitation current. Second, the excitation regulator has gradually evolved into a multifunctional and multivariable controller. With the expansion of the power system and the application of fast semiconductor excitation, many new problems arise in the system, such as persistent low-frequency oscillations on the system contact line, subsynchronous oscillations due to line series capacitance, torsional oscillations on the unit shafts, and negative damping after the application of fast excitation. It is difficult to solve these problems with a single input, single variable excitation regulator. In order to damp oscillations and expand the stability range, it is necessary to apply control theory and computer technology to evolve the simple excitation regulator into a multifunctional and multivariable controller. The third part is the technical standards for excitation systems. First, International Electrical Technical Commission Standard IEC 2A Secret 13-1978 Technical Requirements for Excitation Systems of Turbine Generators IEC Secret 593-1982 Certain Provisions on Excitation Systems of Synchronous Generators. Second, National Standard of the People's Republic of China GB 755-87 Basic Technical Requirements for Rotating Motors. GB-T 7409.3-1997 Technical Requirements for Excitation System of Synchronous Generators of large and medium size. 3. China Electrical Power Industry Standard SD271-88 Technical Conditions for Excitation System of AC Exciter of Turbine Generator 3 Machine System DL-T650-1998 Technical Conditions for Self-Excited Static Excitation System of Large-Sized Turbine Generator Self-Excited System. That's all for this lesson. Thank you.